Before we start, go to today's notes. What I'd like you to do, right next to that circle I've provided, draw two other circles, please. Right next to the one I've provided you. This is just review here, because we're on day 9 already. In that first circle, can you please draw a central angle? In the first circle, please draw a central angle. What you think a central angle looks like. In your first circle, please draw a central angle. In the second circle, please draw an inscribed angle. What you know is an inscribed angle. First circle, central. Second, inscribed. Okay, for the central angle one, no matter how you guys drew it, the vertex should be where? Center of the circle, yes. And for the inscribed, no matter how you drew it, where's your vertex now? Somewhere on the circle. All right. Are we comfortable with those two? Because today you're going to learn your third and final one that could be inside a circle. Everyone all right? So if the vertex can't be on the circle, if it can't be the center, if it can't be on, the third and final way is it's just floating. Okay, it's just floating in the circle, and that's why I give the name floater angle. All right, how to find a floater angle. So using my diagram up here, here's how I find a floater angle. Do you see what I mean by floater angle? There's 4 of them right here. The vertex is C. Is that the center? No, it's not central. Is it on the circle? No, so it's not inscribed, so it's just kind of floating inside the circle. Here's how we find a floater angle. It is half. You take half its intercepted arc, so the arc that it makes, plus its vertical angle's intercepted arc. You add those two values and divide by 2 or multiply by 1/2. All right, so using my diagram up here, give me a floater angle. Using my diagram up here, name a floater angle for me. Here you go, of course, the one. Name a floater angle. Number 1, name a floater angle. ACB is a floater angle. So ACB, this is how I'm going to find it using the theorem. I am going to take half of its arc that it makes. That's what I mean by intercepted arc. So I need somebody to name the arc that ACB creates. And that would be arc 14. Arc AB, so the measure of arc AB, plus, now here's what you have to remember, its vertical angles arc. So look at ACB, look at its vertical angle, and tell me the arc that one makes. What do you got for me? 8? Arc DE, the measure of arc DE, yes. That is how I find a floater angle. Half its arc and its vertical angles arc. We okay there? Floater angle. Because it's going to start getting nuts at the end of class today. All right, basic floater angles. Here you go, basic floater angles. And I will tell you, this is not the center, so that's not a central angle. So it's got to be a floater. So x equals half of $15. What angle does it belong? What arc belongs to angle x? 88 plus its vertical angles arc. 86. Not too bad. They're already labeled for me. So we're looking at 87. I like you guys getting using your calculators to find the average of 88 and 86, right? Okay, right in between. It's fine. Just a little math. Get up there. All right. Bless you. Next one. 65. Is the vertex on the center? Is it on the circle? Nope. So it's a floater. So how did I find it? 65. I took 65 is equal to. I took what to find that 65? 1. What do you got? What did I do to find that 65? 1/2, 100 plus x. Now I know most of you, just by mathematical ability, would try to just distribute the 1/2, and you can do that. That's fine. You can distribute the 1/2. Me personally, I like to get rid of the 1/2 first. All right, so yes, you can do 50 plus 1/2 x and go from there. I like to get rid of the 1/2 right now. How? Multiply both sides by 2. Yep, that gets rid of it right away. I don't have to worry about distributing. I don't have to worry about fractions or decimals. And what does that end at? 130 equals what's left on the right side? 100 plus x, and that's a little easier to deal with now than any fractions you'd give me. So 30 is equal to x. Okay. We all good? Because you're multiplying it by 2, so 1/2 times 2 is just 1. So now it's 1, so that's why that stays the same. All right. Okay, looks like we missed the diagram for you guys on this next problem, so let me give it to you right now. It's a circle, obviously. All right, so go ahead, draw yourself a little circle. Let's fill this in correctly. You're going to have a diameter, so put a center point in there. And we're going to have a diameter going through there called AD. And here you go, AD. You're going to have a point B right here. You're going to have point F right here. You're going to have point C right above and point G right below F, and you're going to connect CG to make a chord. And you guys are going to find this angle X right here. That's X right here. Right there. Okay. Everyone all right? Okay, what do I do with all these numbers that are in a ratio? What have we been doing all year long? Put what with them? X's with them. So what do you want me to label as ABC, arc ABC? Arc ABC is going to be 2x. Where's the 3x go? CD. How about 1x? DFG right here. And then how about 4x? All right. Okay, angle X, is that a central angle? Is the vertex at the center? No. Is it inscribed? No. It's a what type of angle? It's a floater. So before I find any measurements here, how would you find that floater angle? What would you add together and take half of? Hold on. Just name the arcs. That's all I want. Just name the arcs I would add together. ABC, its arc, plus its vertical angles arc, which is DFG. All right. Any way you can help me find the actual measures so I can plug them in? I got 2x, 3x, x, and 4x. Any way I can find those actual arc measures now? Go ahead, Cam. All those arcs are represented, right? And it makes up the entire circle. So 2x plus 3x plus x plus 4x, yep, equals 360. How many x's there? 5, 9, 10? So x ends up being 36. Okay, so go back, plug and chug now. Plug and chug. I need arc ABC. Arc ABC? I'll ask somebody. Arc ABC, now that you know x is 36. Here you go. 5. Arc ABC. Now that I know x is 36.
That'll be 40. Right?
What do we call arc ABC? That's our 2x, right? And what do we find out for the value of x?
36.
So 36 times 2? 72. And what about DFG, everyone? DFG. What do you got for me? 2. 36. All right, here you go. So we're taking half of 108 and 54 degrees. Yes, Amy, go ahead. 2x, so you wanted to do this. Do x equals 1/2 2x plus x, and do x equals 1/2 of 3x. And then just plug in 36 here. I need an actual angle measure. Okay. You could have simplified it down to this point and then plugged in 36. Which would have worked, but I needed an actual angle measure. So questions? All right, here we go. Here's where we're staying the rest of the unit here, and these are on what I call the big dog circles. All right, you got lines flying everywhere. Big dog circles. All right. This will cover all the types of angles we've gone over. Inside the circle, you're going to see central, you're going to see inscribed, and you're going to see floaters now, all in one shot. All right, for these big dog circles. Well, let's label what we have here. DC is tangent. All right, that's what we went over on Friday. Touches it once. Great. AEH. Everyone find that arc. Everyone see AEH? 110 degrees. I don't know how you want to label it. I kind of just draw something from here to here that says, all right, 110. So I know it's the full arc. AG, 80. And the ratio from AE to EH is 2 to 3. So what do you want me to throw on arc AE? A 2x? And what do you want me to throw on EH? A 3x, yep. Before I look at any of the parts, A through E in this case, I try to find out as many of the arcs as I can. The way to be successful in the big dog circle problems is to know what your arc measures are. So can anybody help me fill in any more arc measures up there? Because really the only one I know is 80. Go ahead, Evan. Anything else you can help me try to find? There you go. I add the 2x and the 3x, and I knew from the beginning it was added up to 110. So let's at least solve for those two arcs. So we get 5x equals $110. The value of x, 22. Take it, plug it back in now. Find out what the actual measure of AE and EH are. Instead of 2x, it'll be 44 degrees. So if you want to erase it, put a 44 on top, whatever floats your boat, so you know it's 44. And what about EH now? 66 degrees. Got it. Haven't even looked at the darn choices yet up here. I don't care. Is there another arc up here you could figure out? I think you could clean house right now and figure out the rest of them. You could definitely clean house. Sean, why could we clean house right now?
Well, you find out what GB is, because AB is a semicircle.
Everyone agree? AOB is a diameter, cuts a circle into 2 equal parts. That's a semicircle, 180 degrees. So what's got to be GB there, Sean? 100, because it adds up to 180 degrees. Everyone see the half circle. And then let's do the same thing above. Let's go HB now. HB should be 70 degrees. Yep. All right, we're ready to work now. Good news. We already figured out the first 2 out of the 5 without even looking. GB is 100. EA, where'd we go? EA, there you are, 44. All right, here we go. EFA, everyone locate angle. EFA, because you're going to ask yourself 3 questions every time. EFA, here are the 3 questions. First one, is it a central angle? Nope. Is it inscribed? Nope. What's my only other option? It's a floater. So from today, how do I find a floater angle? I take half of, everyone look at EFA. What arc is created by EFA? Which is how big? 44 degrees plus its vertical angles arc. Here's EFA. I look at its vertical angle, which is here. The arc that this angle makes is 100. Got it. Half of 144. 72 degrees. There it is. And then also start getting in the habit of, once you find these angles, start labeling 72, because you never know what's going to be asked next. That 72 may help us down the road. FEB now. FEB. Everyone locate FEB for me. Everyone see angle FEB. Ready for your 3 questions. Central angle? No. Inscribed? Why? On the circle. Yeah. So anybody remember the rule to find an inscribed angle? Half of the arc. That's it. Take half the arc. Now, some of you may be, oh, FEB, there's F. Okay, but it goes to G. So here's what we're looking at right here. Here's the inscribed angle. What arc does it belong to? GB, which is a measure of 100. So that angle is going to be 50 degrees. And then we come to the challenge. OHD. OHD. Yikes. I know. Oh, hold on. Let me go through the process here. Central angle. Now I'm going to go to inscribed, and you're going to see H is on the circle, so some of you are like, yeah, inscribed. Hey, remember, inscribed, the 2 sides have to be chords. Nah, that's not a chord, HD. But you guys that were here on Friday, help each other out. What's DHC again? That's a tangent. And what's OH? And Sean, when those 2 meet, what does the theorem say? They're perpendicular, which forms a right angle. There you go. 90 degrees. All right. Questions? You guys have plenty of time here. Focus on, hey, here's where we're going. Focus on this now, because tomorrow, what about the angles on the outside? How do I find those suckers? All right, so focus on this now.